So today we are going to start the image formation due to lens. We have done almost everything. Have we done the motion analysis for the curved surface part, or have we missed it? No, I think we have done. Yeah, we have done. Yes. Image formation. So in case of lens, when the focal length is given to you, it means all the calculation already has been done. So either either they will give you the focal length, or they will give you the R1, R2, and mu value. So the end goal is that you should be able to calculate. Sometimes they will give you the F and mu, and that is the special case is the equiconvex lens, equiconcave lens. So if we have equiconvex or equiconcave, so if lens are either equiconvex or equiconcave, the R will be same, and therefore the focal length we can write as. So this is the mu is the refractive index. So we can write 1 by f equals to me minus 1, 1 by plus r minus 1 by minus. So 1 by f turns out to be 2 by r. And we have done this before, that the focal length is basically r upon 2 times mu minus 1. Similarly, if you try to calculate the focal length of equiconcave lens, you can write as mu minus 1 into 1 by minus r minus 1 by plus r. Correct? I'm taking the light ray from the left. And so the answer will be same but with minus r. So what you need to remember that the focal length of concave is negative and focal length of convex is positive. So especially for the concave or convex, equiconcave or equiconvex lens, given the refractive index and the focal length, you can find the radius of curvature. So R is sometimes desirable. Now, whenever the values are given, it is always given with respect to air. So focal length lens always so unless it is not mentioned that it is given in a medium, you have to assume in air. So these are the focal length in air by default. Okay. And now we'll come to the lens formula. So we know the formula 1 by f equals to so for what value of u, the v will have the same distance, of course, on the opposite side. So u and v will have same distance, in which case we have to think. If the focal length is given here and focal length is given here, the f on the left, the convex f will be positive, but the f given here will be negative in sign. When you substitute the value, you have to put to f with minus sign. For concave and convex, you have to substitute positive. If I draw any lens, let's say again the equiconvex. So this is called principal axis. And we need to understand two things. So we have two things here to actually understand. That's called the principal primary focus, principal secondary focus. Therefore, if a light ray is coming this way, and if the beam is parallel, it will converge on a other side. And the point at which it will converge. So this is called the principal primary focus. And we denote by the symbol F, capital F. This is the PPF. So what is the principal secondary focus? So it is actually the point at which if you keep the object, then the light ray traveling after refraction becomes parallel to the principal axis, which is in accordance with the principle of reversibility of light. So if you keep the object at primary focus, which is called the principal secondary focus, then the light ray will become parallel. And if a parallel beam is coming, then it will get focused at principal primary focus. And when I say F, then the sign of F is decided by which focus? So priority wise, we always take the principal primary focus, and that will decide what?
Sign.
The sign of the lens. So that is why, because the principal primary is in the direction of light, so we say F is positive. So it is the principal primary focus which will dictate the sign. In the lens formula, the F represents the location of principal primary focus, not the principal secondary. Now it is important to know the principal secondary because the light which begins from here always becomes parallel to the principal axis. If we do the same thing for the concave lens, now because it is diverging in nature, so if you keep something here, it will always go away and away. So even a pair, this will come here and will go like this. So how to decide the principal primary focus in case of concave lens? So we again take a parallel beam, and this parallel beam after refraction will go like this. So it will not meet on the principal axis for sure. So we have to proceed it backward, and we have been doing this for a long time. So you will just produce it backward. And when you proceed it backward, when you proceed backward, then you can see it will meet the principal axis. So the principal primary focus, the F will be on the left. Because of the definition, how we find the principal primary? We find the principal primary focus by taking a parallel beam as an incident ray, and wherever it either get focused or appear to be coming from, either it converges or it appear to be diverging. That point is called the principal primary focus. I hope this is clear.
Yes.
Yes, sir.
Yes, sir.
Similarly, how to understand the principal secondary focus in the case of concave lens? So, just to do it better. So, if an incident ray is directed towards this point, if an incident beam is directed like this, it is not actually coming in, it is directed. Then, as per the rule, if the incident ray is directed towards the principal secondary focus, then after reflection it becomes parallel to the principal axis. So this will become parallel. So in case of diverging lens, the concave lens, the principal primary and principal secondary will reverse the location, and therefore the principal primary focus will be appearing on the left and our incident ray is on the right. So this will be negative. I hope you are getting the idea.
Yes, sir.
So the idea of principal primary and principal secondary is this. Now, in case of lens, we have two types of principal, primary and secondary. But in case of mirror, we have only one principal and everything else is only secondary. So if you remember the mirror, we talked about the principal focus, and the definition is same there also. The parallel beam will either converge or appear to diverge. And every other thing like which is not principal is secondary, which is off the axis. The secondary foci, so we had infinite secondary foci and one principal foci, and focal excellence, and all the secondary foci was off the axis. Here we have two focus on the axis. Okay, so if I remove the word principal, then we have, if I just say secondary focus, it means it is not the principal secondary, it is secondary means the focus which is off the axis in the plane containing the primary focus and normal to the principal axis. So in case of lens also we have a similar thing. Now this two idea is sufficient to deal with lens problem. You need to be very good with the or with clarity of principal primary and principal secondary. Both are principal because both lies on the principal axis. So the word principal come from the, if the focus lies on the principal axis, we call principal. If it doesn't lie on the axis, we call secondary. But here we have two principal itself, like we have principal both are on the axis, principal axis. So we have two values or two varieties. So this is the basic, you can say the contrast from the mirror to the lens. So when you move from mirror to the lens, this is something which you have to be very careful. In case of mirror, we have seen that if the light ray is passing through the center of curvature, it will just bounce back and go back to the same path. For the obvious reason, it will hit at right angle. Okay, so the angle of incidence is going to be 0, and therefore it will trace back the path. Nothing like this is possible in case of lenses. So we don't have the normal incidence idea where you can hit and come back. So here we have the u and v may be equal. I'm saying not uh, like equal in terms of same side. The object is at primary and image is at sorry, not object is at a location and the image is at the same distance on the other side. That is right. Yeah. So if I use the lens formula again, I want u and v to be equal in value and opposite in sign. That's it. So here, what value of u? Let's say u is d. So if I keep some object here, so let's say I want to know that where I should keep my object so that the image is formed exactly at the same distance as that of the object. But on the other side, and this center of aperture is called optical center. So here we have, okay, this is object, let's call OBJ, I'm not so confused. So O is called the optical center. So there is a naming also. So here is also optical center. So for concave, convex, for convex,
F by 2.
2F.
Oh, sorry, 2F. So
Yeah. So you can write 1 by F as a plus value. Let's write a value. Okay. And I want a V at a same distance on the right hand side. At a same distance on the right side. So it is going to be possible for sure. And if I call D, this is also D. So I can write V equals to plus D and U equals to minus D, and this will become 2 by D, right? Which means D equals to 2F is the value at which the object distance and the image distance will be same, but with opposite sign, which means it is not going to be on the same side. And that is for the reason that in case of a lens, the refraction will occur and refraction will take the light on the other side. So the object and image will be always on the other side. Okay. Now this D equals to 2F is also true for here also. And that is why we have something called 2F notation. So here we don't have the C notation, we have the 2F notation. So we write 2F and we write 2F dash. And what you need to understand is that if the object is going to be at 2F, the image will be at 2F dash. Okay. Because numerically all are same. But if you keep the object at 2F, okay, so if you keep the object at 2F dash, the image will be at 2F. In concave, if you keep the object at 2F, the image will be at 2F dash. So the D equals to 2F is again something that you should be very careful about and should in fact remember these answers. So why these are important concepts? Because without this you cannot draw the images or you cannot take the multiple cases. Because we don't have something like center of curvature as we used to have in case of mirror. So center of curvature concept is gone in case of lens. I hope this part is clear.
yes, sir.
And if you try to do the same thing, you will write 1 by minus F, 1 by V. V is where? On the right side. So object is left. So V is plus D and U is minus D. How much we are getting the answer? 1 by v. So where we are getting the answer? If I keep the object at 2f, the image will be at 2f dash. Okay. Minus. Oh, we have to keep the object. Okay, we have to keep the object at 2f dash actually. So if you keep the object at 2f dash,
So minus f is f dash in right spot.
no, here the f is on the left and f dash in the right. So
So
if you,
numerically we write f dash as minus f.
no, f dash not negative. Here the f itself is negative. F dash is positive here. F is
Okay,
negative.
so
No?
f is only okay.
Yeah, f is only negative. And okay, the way we are trying to solve is 1 by v minus 1 by u. U is minus g. Okay, anyway, so not an issue. So what we're getting the answer? D equals to minus 2f. Okay. So if the object is at this will become only true. Ah, that's fine. That's fine. So we are deriving the answer. This is correct only because f itself is negative, right? So minus 2f is a positive value.
Yes, sir.
So that's why it will take care of the sign also. So anyway. So what we need to remember is that in case of lens, the image formation, we don't use f and c the way we use it in mirror. What we need to use here is f and 2f idea. Okay. So let's do one by one. So image formation. Due to convex lens first. So in convex, we have multiple choice in terms of answers, but in concave, we have just two choice. So as a notation, what do you start? How you start with? You write f first of all. You write f to f. You write f dash, and you write to f dash. So what is f dash here? Anything which you start from here will become parallel. Okay.
Yes, sir.
Or anything which start from here will exactly go here,
Yes.
and anything which goes through the axis will pass undivided. So these are the ideas that you should be careful about. That what kind of radar we can have, or what are the possibilities. So the first question is, of course, when object is at infinity. So if u is at minus infinity, let's say I'm taking the lighter from here. So if the light is coming from minus infinity, what will happen? It will pass through the principal primary focus, right?
Yeah.
And because everything will converge here, it means what you get is a point image. Okay. So will it be real? The answer is yes. So it will be image will be, quickly tell me.
Point size and real.
Yeah, point size and real. And it will be at f
F. Yeah.
real,
Highly diminished.
yeah, inverted and highly diminished. So imagine Okay, if you talk about the sun,
So I have a doubt.
yeah.
So in lenses, how do we judge if whether it is inverted or
That's a good question. So for that, you need to take some extended object. Okay. So let's take some object which is like this. And then draw the line, two lines, parallel lines. That's again easy one. So this will go like this. Correct?
yes,
But the one which will begin from here will go like this. They're crossing the path, right?
yes,
So it is inverted. Is it? The bottom is going up and top is
up,
going down.
yeah, understood.
It is going to be inverted. So if you want to understand the inversion, the simple rule is you take any extended object and you can see the
Yes, sir.
okay.
So which was actually same as the mirror,
Mirror.
no?
Yeah, yeah. Similar to that. The idea of a real is the light ray must intersect really, actually, and virtually it fails to intersect, so you have to produce backward. And then what you perceive, because vision is perception, right? We have discussed. You perceive that it's there. Okay. So image will be at F, real, inverted, and highly diminished. So I want to know the size of the. Imagine this question. There is a question based on this. Generally, every question will find in terms of image of sun. That question is very popular, so one should be aware of how to determine where the sun will form its image. So sun is where sun is at infinity. So if I call this as f dash and this as 2f dash, so sun will be on the left at infinity,
Yes, sir.
and therefore, if I call this is the sun, of course at infinity. So if I draw a line, okay, let me make it slightly smaller. And if I say that actual diameter of sun is a capital D, then how to form the image? It's very simple. You draw a line which is parallel to the principal axis, and it will definitely pass through the focus. Correct.
Yes,
And the
sir.
light ray which will pass through the center will go undeviated.
Yes,
So okay, this is the wrong diagram. So make the diagram correct, because the intersection should be at F, below F actually. Okay, I need to change the. Okay, maybe I'll just modify somehow. This will go like this. Oh, my bad. It will go like this. It will make it easy to match the reality. Yeah, like this. Because what we want, that the image must intersect at, the light ray must intersect near the focus.
yes,
So it will intersect at near the focus, just below the F, and therefore this will be your sun image, which is very tiny, right? Of course, it should be highly diminished. The question is, what is the diameter of the image of sun? What is the diameter of the image of sun? So we know that this angle will be same as this angle. If I call this theta here, this is theta. So see the beauty of physics. So this is the distance of sun from the earth, which is precisely this distance. Let's call this as small d, and this as I can say let's call d dash. You can find a better distance. What is the better way of writing this? Well, let's call it x. And what we know is that this is how much?
F.
Now you can realize that how we are able to understand how far is the sun. Okay, yeah, or let's say if you want to know that how far is what is the dimension of sun? Okay. So you can see clearly from the simple similar triangle idea that d, because it's a small angles, d by x is same as small d by f. Okay. And small d is something that we can observe in the lab. Okay. So knowing that x, we can find the diameter, or knowing the diameter, we can find how far is the sun. So how far is sun? Or let's say if you know everything d and x, you can find the small d. Technically, we can find the indirect value. Like it's difficult to know how big is the sun. So we can take the image and using the similar triangle, we can know that what is the relationship between the distance. So it is known that the distance of Earth to Sun is 1 astronomical unit. What is the x value? X is very famous. 1 AU. What is
Yeah.
AU? Astronomical unit.
Numerical unit.
It is roughly how much? So it is roughly 1.5 into 10 to the power 11 meters. And I might have told you how to get this answer easily. So the sunlight takes roughly 500 seconds to reach Earth. So time taken by the sunlight to reach Earth is 500 seconds. And we know the speed of light is?
3 into 10 to power 8.
So the distance we can attach c delta t, and that is how we calculate roughly. So you can understand 15 into 10 power 10, which is 1.5 into 10 power 11, roughly, not 10. So, and the time was actually calculated. I mean, the speed of light was calculated already using the various method in the past. So this is all about the astrophysics. Like you always use the basic of physics, very basic, not just basic. And using these basic laws of physics, you can find a hell lot of information. So image is a powerful way to understand the astrology. I mean, sorry, astrophysics, astronomy, I would say. So the image formation is not as simple as you believe. Okay, just by looking at the star, we can actually understand a lot of things. By looking at the phase of the moon, by looking at the appearance over the month or the season or the year, we actually infer a lot of things. So every measurement which we perform is indirect measurement. We have never taken a meter scale and gone to the sun to find how far it is. So these methods are reliable methods, and even the error is, let's say, few thousands or tens of thousands of kilometers, which is very small compared to the astronomical scale. So on a scale of astronomical values, these distances are immaterial. If you know how far it is, by even a difference of 1 lakh kilometer, it is like a small value, because in case of a spaceship, we can achieve roughly 40,000 kilometers per hour speed. So imagine 40,000 kilometer per hour means you can actually travel 4 hours, 1 lakh kilometer in 4 hours. So it will just take 4 hours extra for the spaceship to land there. So knowing these things are again important. So this is the basic idea that one should be aware of. And based on this formula, you may get question in exams. Just very simple. Just if you can draw the diagram, you will get the answer. If you will fail to draw the diagram, it's so. So for anything which is at infinity, we believe that it will converge at focus. So this is just way of writing. We use paraxel approximation to get all these answers. The next part is so after infinity, the next option is when object is between infinity and 2f, right? You can say 2f dash because we're doing from
Yes.
1k. So when the object is at is between infinity and 2f, it means we can actually represent on a line like this. So as you come closer to the lens, your image will go farther, right?
Yes, sir.
And where it will go? On the right side, right?
Yeah.
So if infinity is bringing at f, so if you come closer to like less than infinity, it means the image will go beyond f on the right side.
Beyond F. Yeah.
It will be between f and 2f. So how we represent it? So let's say if we have object, in case of lens, it is difficult to draw and convince, but you have to understand actually. If my object is here, so the light ray that will travel now, I cannot do anything like how it will go. We have no option. So what we know that if it is between, so it will go something in between. I mean, you can take two light rays, it will go like this. That's it. And if I have a extended object, then you can do a better diagram in that case.
Parallel line from the center.
So one parallel and one center. That's it. And these two lights are coming from the tip of the object. So it will intersect somewhere in between. So we represent like this. And what we'll call? We call this is. So you can see the image has become certainly bigger than before, right? It's slightly bigger now. So the central ray will go undivided. That is the only thing. But any ray other than center will pass. Okay. And because we're taking both the rays coming from the tip, so these are not a parallel beam. This is a diverging beam, and they get focus somewhere there. But it will focus exactly below this point, and therefore this is the. So if I call A B, we call this as A dash B dash. Let me this. So what we will see here, the image will be. So you can see the image
Diminished,
will be real,
inverted.
inverted, or not diminished, I will say less than object.
Hmm.
That's it. So for here we can say real, inverted, and smaller than object. So the next will be obvious. What is the next question? If you keep at 2f, so at 2f, what will happen?
So extended object.
Extended it, no. At 2f, it will be same size. At
So I
2f,
was
the
asking that extended object you have to do.
yeah. If you take the extended object, if we
Yeah,
have
sure.
the
Same size.
extended object, then it will have the same size. Other than that, will be real inverted at 2f only. Okay, so if it is at 2f dash, it will be at 2f. Okay, and size will be similar, right?
Yes, sir.
Yeah. So those are the things that you need to be, I mean, just you need to be careful about. And the moment you go between 2f dash and f dash, the image will become bigger than the actual size. Okay. And then the next will be, if you come at f dash, which is the principal secondary focus, it will become, the image will go to infinity. Understood? Because that is the principal secondary focus. So light ray coming from the f dash will become parallel to the principal axis. Okay.
Yes, sir.
So
Size will be large.
size will be, you can say, infinite. Yeah, you can call it infinite. And the moment you go to f dash, sorry, beyond f dash and optical center, it will become diverging there. So there is no question of convergence. So do I need to write all, or just I'll take the one specific case, f dash and yeah. That's it. So what I'll do is I'll take just I can mention this clearly, I mean, easily. So when object is between 2f dash and f dash, sorry, at 2f. No, this is at 2f dash. What will happen? Image will be
Real, inverted, and same size.
same size. Okay. So what next? There is no need to draw the diagram, and this is common sense. When object is between f dash and 2f dash, right? I can write like this. Then what will happen?
Real at ahead of
Between,
2f.
yeah, it is also going to be, if it is going to be beyond 2f.
Yeah, beyond 2f.
Inverted beyond 2f and extended. I mean, it will magnify I would say. And then next is what? When object is
At f dash.
at f dash, image will be, will keep up to this moment real only. Will be real You got it? At infinity. Okay. It will be real inverted at infinity and highly magnified. So up to this is a regular thing that you have done in mirror also. The next one is important. So in fact, I will draw the last two diagram. At F, I will draw how it will look like, or how you are supposed to draw in the examination or while solving problem. So if the object is at F, how we represent? So we take two lighters, one like this, and it will pass through the F. In fact, my F is not very nice. That's why the all the problems coming because of this. Anyway, and these two lighters will be parallel forever. It will only meet at infinity. This is how we can say. So infinity means it will be meeting quite far away. So it is like if the focal length is 10 centimeter and if it is meeting at 200 centimeter, it is infinity only. Understood?
Yes, sir.
Yes. This diagram is actually wrong. Actually, there is no need to take this one.
So it should pass from F now.
Yeah, that's what I'm saying. What you can do is you can just think as a beam of light. Just a beam of light is coming here, slightly here. So I can take one beam here, and the beam will converge because it is off the axis. So we have done this that the beam will converge like this. This is the diagram. I was thinking that I'm making some mistake. So you have to think that okay, a parallel beam of light is coming from the top tip of the sun. So the one which is exactly the center will pass undivided, but the one which is slightly above and slightly below will converge below the actual focus, because that is the property of parallel beam, and this is actually your secondary foci. Do you remember the secondary foci definition? If the beam is not parallel to the principal axis, if it is slightly off the axis, if it is hitting at some angle, then it will converge off the axis. If it is parallel to the principal axis, then it will converge on the principal axis. Understood?
Yes, sir.
Yeah. So similar logic will be here. But anyway, it is ratio same. The convergence will happen at F below the axis because the light is coming from the top. So here it is okay. Need to do better. Okay. And the last is what? The last is important.
Between f dash and
Yeah.
equals to dot.
If it is at a distance less than its focal length, right?
Yes, sir.
The moment you go less than focal length, and if you choose any extended object, so the light ray that will travel parallel will pass through the focus, right? But the light ray that will travel from center will pass without a deviation. And as a result, what will happen? They will never meet because these are divergent. So when they will never meet, what will happen? We have to extend backward.
Backwards. Virtual.
Yeah. So now what is the interesting thing that we must understand or remember that virtual here is extended. And because it is virtual, so we have to draw by dotted line. Every virtual thing we draw by dotted line. And the real by bold line. Okay. So now what we can see that image is virtual and therefore it is erect. And that is the logical thing, right? The lines are not crossing each other. So the top is top and the bottom is bottom. Understood? So you can say image will be tell me guys what we can write. Virtual erect
Extend. Erect and extend.
and magnified. So we say magnified, we don't say highly magnified, we just say magnified. I hope this is clear.
Yes, sir.
So these are the image formation due to the various position of object, and you can derive the magnification formula using the similar triangle. So whenever you want to derive the magnification formula in lens, the procedure is same. You draw the ray diagram. Let's say I'll prove it for by drawing for convex lens. That's easy actually. And magnification. And we are talking about which magnification? So again, it is linear or called transverse, or what do you call Either you call linear magnification or you can call transverse magnification. And there's one more name, na? Linear, transverse, and lateral. And the other one is longitudinal that we have seen in case of mirror, right? So what you can do is you just take any position. And the object is somewhere here. So we know the image will be where?
Between F
Between
and
F
2F.
and 12. Okay, so either you can draw completely or you can just get it. A, B, A dash, B dash. This is O. So for this similar triangle, if I say theta and theta, magnification by definition is size of image on size of object. So what is the size of image? What is the size of object? Let's represent this by symbol HO, HI. From similar triangle, what we can say? Tell me. You can say A dash B dash upon AB equals to. See, if you're not comfortable, you can just go by
OA
10
equals
theta.
OA dash.
So it is
OA
O dash
dash.
by OA.
OA. Yeah.
And now substitute everything with proper sign. So what is A dash B dash minus HI? What is AB plus H naught? What is OA dash plus V? What is OA minus U?
Minus U.
So basically HI by HO is V by U only. And HI by HO is called magnification. Size, the value. So we got the answer is, or you can better you can convert here. HI by HO, the value. And then you can substitute. So M is HI by HO, and that is V by. That is the only difference from the mirror. The mirror is having, the mirror it is minus V by.
Yes.
So the linear or the transverse or lateral, all are same thing. It is V by U. And whenever it comes to the derivation of magnification, we always choose the. And why we are putting everything with sign? Because the answer is true for all type of lens. It is not only for the convex, it is also for concave. So we wanted to get rid of the choice that we have made here to derive. Okay. Now when you solve question, again you have to substitute with sign, proper sign. Okay. And negative magnification means it is real, and positive means it is virtual. So for real object, a negative means inverted. It is opposite to So we say that meaning of sign of magnification. And what we have realized that the convex lens is capable of what? It is capable of forming both kind of images, right? Hello guys, my voice is audible.
Yes, sir.
Yes, sir.
So when I say that a lens has formed the image and the size of the image is twice the size of the object, can you guess which lens is this?
Sir, for the given condition on the.
So can we say it must be real or must be virtual? If let's say lens is given to you, is convex, size is double. So can we say the image must be real or must be virtual, or both are possible? A double size image in case of convex is possible either as a real or as a virtual both. We have seen that.
Oh, yes, sir.
That is a takeoff. Even a virtual is double. I mean, extended, magnified. So when I say the size of image is twice the size of object for convex, we have no choice but to assume both cases separate. So while solving question, you will actually put m equals to plus 2 and you will solve, and you will put m equals to minus 2 and you will solve because you have to take both cases. So given a magnification bigger than 1, for convex lens, we'll have two separate assumptions because both are possible. Is this clear?
Yes, sir.
So you will add 2 equals to v by u, 2 equals to v by u, and you will use the length formula for both scenarios one by one.
Oh, yes,
So
sir.
if you use the v, we can attach to u. You can see the answer is minus f by 2, which is clearly saying that it is between the f dash and optical center at half distance, right? Understood? Hello, hello.
Yes, sir.
And if I choose the second option, I will at minus 2u minus 1 by u, and you can see it is minus 3 by 2, right? So it is between 2f, f and 2f, isn't it? So for u and 2f, I mean, if you put something between f and 2f, f dash and 2f dash in a more correct way, then again the size is double, but it is real. So this is the real image of real object, and this is the virtual image of real object. So what I should write here for convex lens, if the magnification, if the size of image is more than is a wrong word, I think. Greater than. Right. So if the size of image is greater than size of object, then take both kind of images. I hope this is clear. So convex lens.
Yes, sir.
Let's go for the convex lens with virtual object, because that is something that we have to discuss in JE context. So far, whatever we have discussed is class 10th syllabus, and I hope you have studied really well there. In ray optics, more than just using format, try to understand the ray diagrams when we are learning for the first time. And you should keep the ray diagram in the mind. That will be very much helpful. So imagine if a light ray is coming this way. Let's say the object is here. So what we know that in case of prism, if you remember, as you go higher, you will bend more. So marginal rays actually bend
Bend.
more than paraxial rays.
Yes, sir.
So if this is the incident ray, so you can see the object position is virtually on the right. And after refraction, because it is convex, it will bend more. So after refraction, it will come somewhere here. So if I take the another beam similar to the top, I hope you can clearly see what is happening. The image is real or virtual?
So real. Image is
So,
real, object is
correct.
virtual.
So for virtual object, image is bound to be real. There is no option of virtual being virtual. And that is the property of convex, that everything is possible possible, not possible. So the final point is that a convex lens can form everything except virtual. And it is pretty much obvious from the previous discussion also. So when it is convex, what it cannot form at all is a virtual image of virtual object, because it is converging in nature. So if a light ray itself is converging, and if you bring the convex into the picture, it will converge more, isn't it?
Yes, sir.
Yes.
So imagine a person who is having the defective eye, and he is not able to focus the light ray on the cornea. It is going beyond the cornea. Let's say cornea is here, but you are able to focus here. Which lens you will use to make it possible? If you want to bring O here, what you will do? You will try to bend more.
Convex.
Exactly. So if a person is having defective eye, and let's say he is having the genetic disease in which his size of the eyeball is more than the average human eyeball size. If your eyeballs are really large, really big, sorry, I made a. If the eyeball is really small, it's the other way around. So for a person with a small eyeball, what will happen? The light ray will converge beyond the eyeball. Understood? And therefore, you need some aid to bend more and bring it at the cornea, and therefore you need someone who can assist in bending more, and therefore what will happen? You will use the convex, right? Understood? So there are two ways in which the disease can be eliminated or remedied. One is if it is genetic, then you have to aid the bending process to bring it back to the cornea. Now, sometimes what happens as we grow old, the refractive index of the aqueous humor and the vitreous humor increases. Okay. So as it will increase, the bending will happen to be lesser. So the light ray will, I mean, you can say the ciliary muscles are becoming weaker with age, and your eye is not able to focus the light ray on the retina. Okay. For those objects which are nearby, because from the nearby object, what happens? If the object is kept nearby, so if you try to read a newspaper in the morning, let's say your grandfather is trying to read a newspaper in the morning, the light ray will come like this from the newspaper, correct? But your ciliary muscles are now weaker with age. So it will try to bend, but not much. It will fail to bend at retina. So how you're going to, help your grandfather? So you will buy a lens. Which lens will buy for him?
Convex.
This is called the hypermetropia,
Yes, sir.
because you're not able to see the nearby object. Because the nearby object always gives you the diverging rays, and to bend on the retina is a difficult task. So with age, we lose this ability. So we need some aid. We need some aid, and the aid is given by the convex lens. So in case of a hypermetropia, we use convex as a remedy. The reverse is myopia. For myopia, what you will use?
Concave.
So it is like you are too powerful to bend the light ray much more than required, right? So the light ray which comes from the far away will be parallel. And your eye is very powerful. It will just bend like this. Again, this is not desirable because we want the focus on the retina. So you won't be able to see which object, the distant object, far object, isn't it?
Yes.
So the far object is not very much clear to your eye. So how are you going to help your yourself? Because generally this is a young age problem. So there are two possibilities. If it is genetic in nature, it means your eyeball size is large. So it's a bigger inside. So the focus happens before the cornea. You reach the cornea. So how are you going to help yourself or your friend with this myopia?
Concave.
So you will diverge a bit before it will enter the eye. And now because your eyes are powerful, it will bend here. So this is exactly what we learned in the chapter of defects of vision. I'll teach you separately, but the idea is here, what is happening and how we can achieve it. Okay. And that is like how you can bring the remedy for the different types of defects of vision. And the possible cause behind the error. These are like not a disease, to be very precise. So sometimes we can manipulate the refractive index of the vitreous humor. The aqueous humor is the when you cry, what comes out is the aqueous humor. So the aqueous humor is it can be drained out, okay, and vitreous which remains there. And by changing the refractive index of vitreous, we can actually get rid of this myopia. So sometimes what happens, the myopia goes away as we grow old. Okay, so that's very interesting. That myopia
So
goes.
hypermetropia is for can also happen in young people.
Yeah, it can happen young when it is eyeball issue. So this is the eyeball. Huh? Your eyeball is shorter. So
Yeah.
you may have this problem by birth also. Because if the eyeball is shorter, then the focus will be here, na?
Oh,
So
yes, sir.
you need some support in the very during the child during the after the birth, maybe when you are 2-3 years old, you need this.
So because I'm having that problem.
Oh, so that problem is basically the shorter eyeballs. Now, LASIK surgery is possible to remove this permanently. Okay. If it is due to the aqueous or vitreous humor, then probably some liquid drop chemical will resolve the issue. But if it is the eyeball, then there is something called eyeball rectification. So they use some sort of laser surgery, and because these dimensions are, see, I mean, let me tell you something. The error is only of millimeter size. That is interesting. So whether you will see something clearly or not, it's only matter of fraction of millimeter. So of course I cannot compress the eyeball. So the laser, what it does is it softens the tissues actually, or we by removing some tissues we allow the movement of the cornea. So we shift the cornea slightly, and it is like a mechanical process, but it's a very delicate process, and you can totally get rid of this hypermetropia. Because these are not disease. I mean, any eye related issue is not a disease. It is like all about refraction. I mean, something is going wrong. So either this is called the curvature issue of the eyeball. With wrong curvature, if your eyes are not as curved as it is supposed to be, then the issues you will face is called astigmatism, okay, which is called look London, talk to. You look right, you talk left. Or you can say your eyeballs are tilted all the time. So your face and your eyeballs are in the like facing in the different axis. So your human face will face somewhere, but the eyeball, because they have the plane of curvature in which the light should be received from the image is not symmetrically placed. It is asymmetric. So the word has come astigmatism because it is asymmetric, and then something, there's one more word I'm forgetting it. Okay. So because of the asymmetry in the shape, actually, that happens. And okay, these are like defects of vision. That's why it's called defects of vision. It is not studied under the disease process. Okay, it is not a disease caused by bacteria, virus, protozoa, and so on. So we have seen the image formation by the which lens? Convex lens. We have seen how it behaves, and the really catching point that one should remember is that the virtual image of convex is magnified. What is the image formed by the plane mirror? The virtual of plane is, so plane mirror forms image
Virtual image.
virtual for real and real for virtual, and the image is having same size, so there is no magnification. So we have exactly one magnification. M is 1 for which mirror? Plane. So when you go to other mirror, you see either increase or decrease. Just a minute. So image formation into concave lens. So here we don't have multiple cases. We have just two cases. And how the F will look like here? If you remember, a light ray coming parallel to the principal axis after reflection will diverge.
F will be in left side and F
Yeah.
dash in right.
So this is basically F. And because if I take even one more light ray similar to that, so these light rays are never going to meet anywhere. Right? So which kind of image you will say? Virtual.
Virtual image.
If it is virtual, it is always erect. So the top ray is top and bottom is bottom. So they are not going to intersect, right? So virtual rate, and then we can say highly diminished. Okay. So and at F, if you take any other diagram or any other case, so I'll take an example of extended object. So this light will appear to be coming from where? F, right? Is this clear? And other light ray, if I choose from passing through the optical center, will pass undeviated, right? So they will not meet, but they can meet only if we extend backward. So this is the point of intersection. And you can say one is virtual, other is real. So the final will be virtual because the light rays are not meeting, right? Is this clear?
Yes, sir.
So the image will be virtual, erect. And now the interesting thing comes. Concave can only form the, and see what one thing is clear here. All image will eventually fall here because the scope of this line is here only. Correct. I'm getting this idea what I'm saying. No matter where is the object, the intersection is only possible where?
So can you repeat again?
I'm saying that in this case, the image will form only between O and F. No matter where is this object. Why? because the scope of the dotted line is between O and F, right? The line passing through the F can be intersected only when some light ray is between this F and O. Not getting it right.
So what?
See, the light coming parallel to the pencil axis will pass, will appear to be diverging from point F. So, just this light ray will, we can draw only from here to infinity, right? From here to infinity.
Yes.
So whoever will intersect this light ray will eventually give the image.
Yes.
So can we intersect this light ray beyond this point, here or here?
No.
So where can intersect?
Only between F and
So the image is bound to be between.
O and F.
This is what I'm saying. It means all images will be formed from O to F. That's the end of the world. Is this clear?
Yes, sir.
And you can see it is diminished, or you can say it's smaller than. And this is the biggest contrast. If I say a virtual image and if I say it is magnified, which lens it must be? Convex. Because concave forms virtual, but it is never magnified. It is always smaller. It is clear.
Yes.
Very. So if you take any other point, let's say if you take F, the image will be.
Sir, any other point?
If you are at F, let's say if the object is at F,
Yes.
so where the image will be? Okay, take another diagram. So now let's say the object itself is at F. Here nothing will happen. It will, all image will be between F and, okay, now I have to need to mention, and between O and F. That's it. Now imagine if the object is here. Or let's take here. Try to draw the diagram. The lighter with this will go from where?
So it will be between
And other will be. So it is still between, no?
between.
So no matter what I draw, the answer is fixed. If I take here, then what will happen?
So still between. So
Yeah, there is no option. The only thing is, as you
so it will
go,
always form between the object position and the pole of focus and
yeah. So in terms of the terminology that we use, we call ONF. The only thing is, as you move closer to the length will increase. That's it. Okay. And if you make the object almost touching the optical center, then the length will be almost equal. Understood?
Yes.
This is also obvious from the formula. So when u is 0, v is 0. Okay. Which is like if the object is here, the image will be here. And what was the magnification? So f by u plus f. And what is u here? 0. It means it will become of same size. For paraxial, I mean object, if there is a tiny object close to the optical center, then it will be of same size. Understood?
Yes,
Is this
sir.
clear? Okay. Now comes to some typical question that you should be aware of. We can take the
Check
advantage.
into the previous page. Not done, sir.
Okay, you want to say something?
Not done, sir.
So let's see if I have a parallel beam of light. So maybe it's like a laser light. Generally, we play with. It's a very zoomed diagram. And now this light ray is going to hit a convex mirror, convex lens. If it will hit the convex lens, what will happen?
Diverge. Oh, sorry, converge.
The beam will converge. So where it will converge? At f.
Yeah. If
If I
it's
call this is
direct shape.
f1, if I call this f1, the convergence distance is definitely f1 away. Okay. I want to make the beam again parallel using another convex lens. I have to this where I should put this. Let's say the focal length is f2, different from the first. Where I must place this in the path so that the light ray again become parallel. Here, 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 where? So here there comes the concept of secondary focus. The point of convergence is this point is f for the first, and if it is f2 dash, we know the property of light. And what we know? If this is exactly f2, the light ray after refraction becomes parallel, isn't it?
Yes.
Do you realize this? The beam,
Sir, it will have the same width, right?
no, it will f2 will change the value.
The thickness.
Yeah, the diameter will change. It's a cylindrical beam, so diameter will change. And that is our question. The diameter relation, which is again very simple. So if you want to make the narrow beam, the second lens should have a small focal length or big focal length.
So less focal length.
Correct. So and then
So for that condition, focal length should be less and nu should be higher than the first one.
no, when focal length is given, then we should not be worried about f. If the diameter here is d and this is small d, can you relate these to d and d using again symmetry triangle?
Yes, sir.
So what we can say, capital D by f1 is d by f2.
F2, yeah.
So the new d is how much? f2 by f1 into. So if you want to narrow it, what will happen? The f2 should be less than f1. If you want to magnify it, the f2 should be more than f1. That's logical, no?
Yes.
If you look at the red diagram, that's meaningful. That's logical. So the idea is simple. A parallel beam, after passing through two consecutive lens, can again become parallel. And if you keep the focus both lens equal, then the beam will have the similar size. If you change the f1, f2, the beam will either have more or less size. So now it is up to you to choose that which kind of. So generally they ask the intensity of the incident beam and intensity of the final parallel beam, I dash. So intensity is defined as amount of energy per unit area per unit time crossing some cross section. So if I draw a cross section here, how much energy is crossing this cross section? I. Now energy is fixed. The source is the same energy is passing forward. By narrowing the cross section, if you narrow the cross section, what will happen? If A becomes less than, the energy will be more concentrated, so intensity will increase here. Understood?
Yes. So in the second beam,
Yeah.
I
So
dash.
second, yeah, if second beam is narrow beam, it will have more intensity. If it is broader beam, it will have lesser intensity than before. So because the energy we are not losing, so whatever energy is coming from left, the same energy is going here. So dE by dt is same for both. So what is different? Only the area. and therefore I can say product of I into A is same as I dash into, because I into A is what? So where is the intensity maximum? Almost infinite. It is at the cross section here, the joint. If you bring anything there, it will be so intense, it will burn it. Right? This is something that you must have
Yes.
played in your childhood using the lens, and by focusing the sunlight. You can burn paper, you can burn small dry wood and all. Have you done this before?
Yes, sir.
So I did this experiment in class 5th. And what I used to do is, like, I went to market, I bought this 2 rupee lens. The price was 2 rupee only. And I used to burn the skin of my cousins, my siblings, also. My brother, my
Sir,
sister.
but the focus will vary, right? If the rays are marginal,
It is
if
not
the
very
lens is
intense.
big
I
enough,
mean,
right?
pardon?
If the lens is big enough, then the focus is vary.
Yeah, focus is never zero. It is only theoretically zero. It is always a diffraction gives you a small width. That is also, I mean, like proof that the light suffers diffraction, and the ray optics is approximation to the diffraction. So you can buy a lens, you can try to focus it. You will see it will become narrow for sure, and the narrow will have some sort of very nice pattern. You can see the center of the narrow part will be brighter, and the edges will be like lighter. So if you have lens at home, you can go to, I mean, open air, let the sunlight to enter in the afternoon, and see the pattern on a paper. You can see something really nice. Take a picture and send
So
it to me.
yeah, the brightness fades away.
Yeah, it fades away. You have the lens.
Yeah, it's nice. Oh my bad.
So you can always see all this. It is always there. The light is, this chapter is logical. I mean, so the intensity relation will be asked. So the I dash in this case will be I by A dash, and in the area of cross section will be diameter square, right? And the d by d is what? F1 by. Eventually, this will boil down to this simple relation for intensity relation. So F1 is more than F2. It is more intense. If it is less, it is less intense. So intensity is the how small, on how much area, what energy you receiving. So energy receiving per unit area per unit time is called intensity. We have done this in wave and sound, right? We have done, isn't it?
Yes, yes, sir.
So okay, the next is I want to achieve the same using the two different lens. So I'll use convex and concave combination. So for convex and concave combination, things will be slightly different, because for concave to make parallel beam, the incident light should be what?
For concave to make
A beam parallel. The incident light should be converging
yeah, no, converging.
at F only. It means the F of the, let's say this is F2 value wise. So F2 dash will be here, right? If a light ray is coming, if a parallel beam is coming, and this parallel beam after refraction is trying to come here. What will happen?
So your voice cracked. Can you repeat it?
If the parallel beam after refraction is trying to get focus at f2 dash, f2 dash is the distance from the second lens, concave lens. So f2 dash is the principal secondary foci for the
Convex lens. F1.
concave lens, and it is principal primary focus for the convex lens. If it is both at the same time, what will happen?
Front
The
lens.
beam becomes parallel. Understand?
So no, I got confused after.
No problem. So that's why I said this is the most important part to understand. Think about it. When a concave will make it parallel?
When it will be converging to focus.
When the incident is converging, right?
Yes, through focus.
So it's focus, right? Which focus? Principal, secondary.
Principal.
Principal, secondary focus.
So secondary.
Yeah. So now so a parallel beam will become again parallel. And in this case, the beam is going to be always narrow or broaden. It is always narrow. Understood? So if the light ray is coming from the left to right, because f1 is always bigger than f2, no? You can see it clearly. This is only possible when f1 is here and f2 is only this much, no?
Yes.
So in this case, f1 is always going to be more than f2. So IA will be same as I dash A dash. So IA equals to I dash A dash. So I dash is how much? Which will become I into. So I dash, because we are making it narrow, so I dash is going to be very, very larger than. We can achieve the higher intensification process using the combination of convex and concave. And again, these things are important. I mean, if we have a furnace in which the ignition is done using the same. So what is it? There is a furnace which will ignite if the light will reach certain intensity. Let's say we have something like a solar furnace. So what we'll do is we'll make the two lengths movable. One is fixed, which is the convex, and then we'll keep the F2 movable. So by moving to a certain distance, we can achieve a desired intensity, and therefore we can burn. So we can actually convert this into a device. Okay. A device which uses the natural light to create the furnace action. Okay. So if you are in a, let's say you're doing the what is a show called Wild versus Man. Yeah, something like that I have heard. So you can be part of that Wild versus Man. If you just use basic simple physics to burn something. So keep this device ready and take the sunlight, direct sunlight from the top, move the slider, achieve the desired action, and you can lit the surface uniform. So we need to carry a bigger one so that you can create a furnace kind of behavior. And then you can boil water easily. You can put a pot here with this arrangement. Okay. Then you may be wondering, so how I can use it as a pot. So then I have to use a bit of more physics. So what I'll do is I'll bring a mirror exactly at 45 degree. So, so I will have because this is something like this, right? The light ray will come from the top. So it will kind of create the beam is coming here and it will become beam like this. But I again need as a furnace, so I'll put a mirror here at 45. So this entire beam will bend like this. And I'll put one more mirror here and I'll bend it. So now I can put a furnace on this. So I will put a pot and something to receive. And so this is a nice project if you can really achieve this. And probably can sell it in the market. The solar cooker, free of cost. Okay, so ideas really work if someone is there to implement it. They can play with this idea, and if someone is really good with the Jugaad technology, like those who know how to create the objects, I can give the theory. If you want, you can create it, and you can then patent it, and then you can, if you need more temperature, just like the gas burner, right? Okay. And if you want to have a larger achieve, you can put two convex lens, or you can bring two or three, and you can achieve, and then you can make an array of such lens, array, so that you can create a really nice furnace kind of property. Yeah, this could be very powerful idea. Anyway, so now we can go to the next one. Experimental determination of focal length of lens using displacement method. Okay. So what is this displacement method? In this method, what we have is we have a screen actually, and this is the axis. That's why. And here we generally use a candle. Let's say we have a candle. So we have a candle. Okay. So we have a screen. So now this candle and the screen are fixed quantity. We don't change it. And we take a convex lens. So this is convex lens. What we do next is we slide the convex lens till the instant the first sharp image is obtained. So what will happen if you move like this? If this U, if this U and this V if the V represents the V of that given U, you can say the image will be formed on the screen, isn't it? Now, can you tell me which kind of image will form? Magnified or diminished? What kind of image will form? Magnified or diminished image? So magnification is what? And you can clearly see the first image will be, if you move the lens from left to right, the V is bigger than U, right?
Yes.
So the first image will be
Magnify.
magnified. And the U and V will be in the like a relation with the focal length, 1 by V minus 1 by U question by U. Okay. So the magnification number 1 will be V by U. And if the height of the object is HO, so this will be HI upon HO. Fair enough. So let's take U and V as values. That's easy. What we do next is we displace. That's why the name has displacement. We displace this lens, and we displace this lens till we get the another image, and we displace by a value called X. Now, the next image will form if it will follow the principle of reversibility, which means technically this should be V, and then this will be U again, right? Because for every pair of values, we can have the image, right? Do you realize this what I'm saying?
Yes. But this time it will be
Diminished.
diminished.
So the first image formed, so I can say M1 will be V by U, which will be the first image size H1 upon H2. H1 is the image of the size of the first image. H1 is size of first image. But the second magnification will be exactly reverse or diminished. And we have a very nice relation. What is the relation? M1 into M2 is what? 1. Because M1 is inverse of M2, isn't it? And this implies H1 by H naught into H2 by H naught is also 1, which is in a way blessing that you can exactly find the height of the candle, assuming the experiment is not performed for long duration. Otherwise, the candle will melt. That we are not taking into consideration. So, by knowing the first question, they will ask you that by knowing the two images size, you can actually determine the actual size of the object. So, this will be your first question. Is this clear so far?
Yes.
Okay. Now, what we want next is the difference M2 minus M1, because M1 is bigger, M2 is small, so I can take the difference. So V by U minus, which is V square minus U square by UV, isn't it?
Yes.
So but this is of no use as of now, but we can make it useful if I use the lens formula. What is the lens formula? What is the lens formula?
1 by v minus 1 by
1 by V minus 1 by U plus 2. Very good. So we want to use X somewhere. If U becomes U plus X,
Sir, what are we trying to find?
yeah, I'm trying to relate F with X and M1, M2. The final answer will be, because this is the displacement method, so we have to use X to get F. So by when in a lab, you displace the lens to get the second image, or it is a second sharp image. So X is the known quantity in experiment. So what we know is X, and the U and V, we can actually use it.
We can use u plus v equals no, sorry, u plus x equals v, and then we can substitute.
Yeah, U plus X equals to V. Yes, we can say it. So what is X equals to? V minus. Understood?
Yes.
Okay. So I want a relation. Now this X we can get. That's fine. So M1 minus M2 is how much? You can see M1 minus M2. We get as okay. You can add this as V minus U into V plus U upon UV. And this is X so far. So what we get next is we have got it. So what we get in right here is M1 minus M2 by X equals to U plus V by UV, which is actually 1 by U plus 1 by V, isn't it?
Yes.
Now, what is the formula for focal length? 1 by F equals to? See, our U and V are values, as I said in the beginning. I am taking value. So, what is V here? What is U here? This is like tricky part. I didn't change the symbol. I kept the symbol U and V for the values. And that is why this answer is how much? Same answer. Do you realize this? So M1 minus M2. F is how much? So this is the famous formula of the displacement method. Displacement method. So generally, they will ask you this formula directly. I mean, you should know the answer. If you want to derive it, you can derive it. There are other ways of doing this. I mean, of course. So now we have seen the product of M1 M2, which gives you the height of object. And because we are doing experiments, so we need to understand that what are the things that we are going to observe. So X is something which we observe, and magnification is definitely we can observe, right? Because we can see this image on the screen, we can see the object in reality, we can take the ratio, we can know the M1 M2. So generally M1 M2 is this is a nice way of writing. Why they write this way and they're very happy about it, I don't know. But this is how it is written in various texts. So F equals to X by M1 minus M2. And the other thing I wanted to say is, what is the ratio of M1 M2? If I take the ratio, it is V by U whole square. Okay. Is this of any use? Okay. And now, yeah, one more thing I can do is, if I choose the screen distance from the object as a finite, this is a finite value. This distance is also finite because the object is fixed, right? So so the V and U can be expressed in terms of the separation and displacement, and therefore M1 by M2 is V by U, which is basically D plus X by whole square. This is also nice one. What else you can do? Then you can write as and this we can write as A plus B whole square is A minus B whole square plus 4A. So what I'm trying to achieve, okay, I'm not trying to achieve anything. That's why these are of no use. All right, I think this is sufficient. So if they ask you some question, you know how to proceed.
So you have to always derive from the start or remember some formula.
You remember this formula at least. But you need to know this formula, you need to know this formula. And this is the starting way of derivation. So let's say if I give you the screen distance and the object distance is 100 centimeter. If it is 100 centimeter, and if the first image is at 20 centimeter, the second must be at 80.
80 centimeter.
So from 20 to 80, how much you have displaced?
60.
60. So what is the x value? 60. Okay. Of course, this is of, I mean, I don't know what is there may be some use, but right now I don't recall what use we can actually do it. There was some problem in which we were supposed to use something like this. So, example, object screen 100 centimeter. This is, let's say, 30 centimeter. How much we need to displace next to get the again image on the screen?
40.
This is 40. So the M1 will be how much? Because this is 30, so 70 by 30. M2 will be 30 by 70. Correct? So
Yes.
7 by 3, this is 3 by 7. So M1 minus M2 is how much? 7 by 3 minus 3 by 7 is 49 minus 9, which is 40 by 21. Am I right?
Yes.
So what is the focal length? 40 by. So this is how you determine experimentally the focal length. Understood?
Yes.
Maybe. And if I give you the height of the two images, you can find it. Let's say the first image is 9 centimeter long, second is 4 centimeter long. What is the object actual height?
6 centimeter.
These are the questions that you come across. Understood?
Yes.
The other thing you can do is, first of all, there is a condition to make the image on the screen. If we have a screen, and if you have an object, and if it is given as D, and if you bring some lens here, so if I say this is X, this will be V minus X. F is the focal length. What you can write? 1 by V minus 1 by U equals to 1 by F. Let's substitute the value 1 by 1. D minus X positive minus X plus F. F is value, let's say. So 1 by D minus X plus 1 by X. So what you get is X plus D minus X. So df equals to so for the x to have any real answer, the discriminant must be positive, which means
Greater than 0.
d square so the first
So why
condition
not
is
equal to?
yeah, pardon?
D greater than equal to 0.
4f.
So no, D greater than equal to 0.
Equals to will give you exactly one image. We want two distinct image.
Oh, yes.
If the roots are repeated, then only one answer. No? So for we need real and distinct, then more than 0, right? So to solve such question, first we check is the D more than 4f. Let's say if it is given, so these kind of answer you should know. So yeah, this is the answer, and now you can find the x equals to x equals to how much? Or you can say, let's say x1 and x2 are roots. Then the sum of the root is how much? Minus b by
Minus B by
which is exactly the u plus v equals to d formula, right? And the product of the root is how much?
C bar.
So the difference of the root is how much? The sum of the root whole square minus 4 under root. Understood?
Yes.
And this is called x, the displacement method. I mean, the x of displacement. So x is how much? X is under root of the sum square and the x1 x2 is how much? So d square minus 4fd is x square. 4fd is how much? So the other formula is d square minus x square uh, by 4d. So this is another formula of focal length in terms of the total distance and this is exactly this is same answer as the before answer. Let me prove it how it is. So m1 we can write as m2 is so m1 minus m2 is how much? Sorry. X1 so in the first case yeah, that is fine, but we need to write the answer in terms of x1 x2. So the first is x1. So t minus x1 by x1. The second is how much? D minus x1 minus x because you have displaced by x upon x2, right? I think this is correct, no? And because this is confusing, why this is confusing? Because the symbol I have used for displacement as x and this has also x, so it has messed up everything. I think I can choose something else, y or z. You want me to change the symbol, or is it okay if you have understood?
It's okay.
Okay. So yeah, we can write like this, or we can write as x2. That's also fine. And x2 minus x1 is how much? I think if x2 is bigger, okay. So the LCM will be x1 x2 dx2 minus x1 x2 dx1 plus x1 square plus x1 x. F. Oh, fine. Yeah, that's correct. So it's a rigorous calculation. If you write like this, but we have the easier way of writing that we stick to that. So I hope this is clear.
Yes, sir.
Okay. So next we can move to the next concept.
So this lecture is till what?
Pardon?
This lecture is till what time?
What is the time now? It's 5. Ah, oh, today is only for 2 hours because I have to start lecture after half an hour. So I'll take a break. Okay. So we'll continue the other part, which is called the equivalence. I mean, equivalent focal length of combination of lengths, or you can simply say combination of lengths. Yeah, so that's a big topic and the most important topic. Okay, fine. So we'll see you in the next lecture
Tomorrow.
tomorrow. Tomorrow is what? Saturday.
Saturday.
Yeah, we will have tomorrow in the afternoon, hopefully.